The following video is a screen capture of a live modeling session in which we're going to create a Maestro module from the provided Rhino model. The Rhino model, as shown on the screen, has just been opened. We haven't made any modifications or done any pre-processing to the model. Everything will be done from scratch on the original model. We're going to assume that everyone is fairly familiar with the layout of a Maestro model, how the hull is broken into various modules, and each module contains the various entities comprising the FE model. The module that we're going to create is one of the hull modules. It'll look something like this when we're done. We have the strakes defining the shell. We used quads and tries to define the bulkhead, placed beams on them. The frames were built up from quads and tries and we used what is known as a compound in Maestro. The longitudinal stiffeners are girders on each strake. The center vertical keel is another strake with beams forming the flange at the top. So all of this will be created from scratch, but in the end we should have something that looks somewhat like this. With regard to the video capture software, it adds a few features when it writes out the file. You'll notice that the cursor is highlighted as it moves around the screen. Also, whenever the mouse is clicked, you should see a little circle appear. And when the scroll wheel is used to zoom in or zoom out, you should see a small red arrow indicating the scroll wheel is active. These are things that are added by the software when the video is written out. During the actual working session, you don't see any of these effects on the screen. So let's get started. The first thing we'll do is we're going to work on one of the hull modules here. We'll just call it Module 5. It would be the 5th module working forward in the hull. We're going to model this one because it's probably the simplest module in the hull, so we'll start with that one. It's a good sample module. We typically do the hull and the superstructure in separate modules. They don't have to be, but just as a convention. And many of the things with the Maestro models are sort of a user's preference. Each person will have their own style in terms of what they like and how they want to model. This is just a sample of how one method of creating the model. All of the things that we're doing in Rhino here could be modeled in Maestro directly. We just want to take advantage of the fact that there are typically 3D models of most of the ships nowadays, and also there are a lot of advanced modeling features in Rhino that we'd like to take advantage of. We've written a few scripts that help convert some of the geometry entities in Maestro or in Rhino over into Maestro. Primarily, we can easily transfer all of the strakes from the Rhino model into Maestro by simply creating all of the endpoints in Rhino and then creating a polyline that tells Maestro how they should be connected. And that's what we're going to be doing here. The first thing is we'll turn off the deck house so that we don't have that in our view. I think some of the stiffeners are shared between the hull and the superstructure. So what we'll do is just hide the remaining pieces that we can't turn the layer off on. And if we turn off the hull and the frames, we'll turn off the engine girders and the other stiffeners and such. We'll create a new layer, and we'll put it down at the bottom here. We'll call it geometry, and this is where we're going to place some construction geometry that we can use to break up the model without having to clutter up the existing layers. These are all just temporary pieces, and it makes it nice and easy to turn them off. First thing we'll do is create a large surface to act as a cutting plane So we'll just do corner to corner, make sure it covers the entire model. We need one at each module boundary, which is going to be at each one of these water tight bulkheads. So what we'll do is we'll take this plane and Control-C and Control-V to cut and paste. So now there are two copies of that plane at this location. We'll use set point, and we will just change the X value of this plane to the next boundary, and we'll do the same thing over and over. Cut and paste, run set point to change the location of our new copy. And we'll do that all the way up the hull. And now we have our cutting planes. I guess we don't really need one at the end there, so we can turn that off. And we will turn off the deck here. Now for our stiffeners, we want all of the deck and hull stiffeners, because those are going to be our endpoints for this module. And here are the boundaries of the module that we're interested in. So what we'll do first is grab all of the existing stiffeners, and we're going to make a copy of them and move them into a new layer, sort of a working layer, so we don't disturb any of the original geometry. We'll create a working layer, and we'll call it Endpoints. So since we have everything highlighted, we will Control-C and Control-V to cut and paste, go into Properties, and move them onto our Endpoints layer. Now we can turn off those stiffener layers, and we have our own copy of these on the endpoint layer. Since we only want the portions of this in this area, normally what we would probably do is split these at each boundary so that we only have to copy them once. And actually we'll do that here as well. So we'll grab all of these and split them. We'll split them using those two boundaries of the cutting object. So now we have all of those as separate items. We can hide the ones we're not interested in for the moment. Now that's the majority of the endpoints that we'll need for creating our model. Now since we're going to have a symmetric model, we're only going to model half of this just to save on some of the modeling effort, and we'll just mirror it in Maestro. This doesn't have all of the endpoints that we're going to need. You can see the intersection of the deck and the side shell is missing. The bottom of the center vertical keel is missing. And I believe there might be a knuckle curve missing in there as well. So let's turn the hull and deck back on. And you can see we're missing that endpoint to define the edge of a strake there. So what we'll do is we will do curve from object, and we will copy the edge of the deck to extract that line. We're also going to want this knuckle, so we will duplicate that edge as well. The chine down here, we're going to want that edge for an endpoint. We're going to want the inboard chine. And we can select all of the endpoints to highlight them so we can get a better view. Panning around, I think we have most of the lines that we want now. I did make one mistake there in that I had the geometry layer as my current layer. So I think it probably created some of those lines on the geometry layer. So what we'll simply do is grab all of those and move them to the endpoint layer. Turn off the deck and hull, and as we did before, we'll want to split those new lines at the boundaries. So we'll split, grab those planes as our cutting object, remove these from the selection set, and then just hide those pieces. And now we have almost everything, but there was the center girder, and we're going to want the bottom of that. Or I guess we could also have used the hull. Maybe we'll use the hull edge. And there is a bulkhead in here, and we're going to want a stiffener or an endpoint at the top and bottom of that as well. I'm going to turn off the geometry layer, and again I have the geometry layer active, so we're going to move that line I extracted from geometry over to endpoints, and we'll make the endpoint layer current so that doesn't happen again. And turn those off for the time being so we get a better view, and we will duplicate the top and bottom of that frame. Now we can turn that off. We'll turn our geometry back on. Those three curves that we still need to split, we will split them, remove them from the selection set, and we can hide everything else. So we'll turn off the geometry. We have most of what we need for our endpoints. Now there is no stiffener on centerline. So what we're going to do is we will turn the hull back on. You can see where the center of the hull is, and we'll turn the deck back on. Since we're going to mirror about the center line, we will need an endpoint on center line. We'll be able to get rid of all of the curves on the one side because we're going to be mirroring. But to create those, we'll go into the profile view, and we will create a large surface. And we should probably do this on the geometry plane, similar to our other cutting planes. And we'll create intersection curves for two sets. One will be the hull and deck. The other will be that centerline plane. We did them as sets so that we don't, when we did the hull and deck, we don't wind up with an additional copy of the curve at the intersection of those. So we can now grab all the objects on the geometry layer, since that was active when it created the new line, and we'll get rid of the planes from the selection set and move those over to the endpoints. We won't need that again, so we'll hide it. We can turn off the hull and deck now. And again, we'll grab these lines, split them with the module boundaries, unselect the pieces we want to keep, and hide everything else. Now we can get rid of the endpoints that are on the opposite side of the model from what we're keeping. And now we have all of our endpoints. Now for the script that exports these to Maestro, all we need are all of these lines and a polyline that connects them all, so that Maestro knows how to connect these endpoints into the strakes. Now the script as it is right now only accepts single segment polylines and lines for the endpoints. Most of these are actually curves because they were copies of the original stiffener traces. So what we'll do is we'll grab everything, turn the points on, and the easiest way to convert these to lines is just to delete all of the internal control points on the curves. Now that they can be curves, but with only 2 points on them, they're effectively lines. And they'll be fine for using in the script. One thing we do want to do is check for duplicates. So we'll do select duplicates. There are none in here, so that's good. The other thing we can do is make sure everything is joined into a single line. Right now, if we select everything, we have 49 curves. If we join them, unable to join curves, so everything is already as a single segment. Another thing we might want to do is to check the direction. Now this isn't important, or isn't required rather, but it's nice sometimes to have all the curves facing in the same direction. Makes it a little easier to generate the endpoints to create the polyline for connecting the strakes. Because now, since they're all facing in the same direction, we can use the curve point object, and we'll mark the curve start. Since they all start at the same end, we have all of our points. Now to create the polyline to connect these things, first we'll start with the deck edge, or rather the deck. We can grab them all and do curve, polyline, through points, and you'll see it just created a polyline through all of those points. We grab everything, deselect the deck points, and add that 1 point back in. We can run the same command, do polyline through points, and now we have the 2 polylines that will show how all of the other endpoints need to be connected. We'll check the direction on those, because the direction will tell Maestro which side the frames should be on. Since these are both going from inboard to outboard, the frames would be, say, on the inboard side of the hull, but then they would be on the top of the deck. So if we change the direction of one of them, so that they're both moving in the same direction, the frames will either both be on the inboard portion of the hull, or the internal portion of the hull, or the outside portion of the hull, which is very simple to flip in Maestro. So now we can actually run the script to export these into Maestro. So we'll pre-select all of these under Tools, Rhino Script, Load. I have these already loaded in here. So we'll grab the Export Endpoints script and run it. and actually we'll run it from scratch. We won't pre-select anything. First thing it does is, if you haven't selected anything, it'll ask you to select the endpoints. So we'll do that now. These are all the endpoints we want to select. Now it wants to know, and this is an optional step, how these endpoints will be connected into strakes. If you don't provide the curves telling it how to connect them, then it'll just write out the endpoints, and Maestro will read in the endpoints, and you'll have them there, but you'll have to manually create the strakes in Maestro. If we give it these two curves that tell it how they should be connected, it'll write out that information as well. So we'll call this one Module 5. And whatever name you give this file will be the name of the module that Maestro brings in. And now we can switch over to Maestro to see how well this worked. Now we're going to get rid of this model because we're creating ours from scratch. So we'll make a new one. Actually, what I'm going to do is open this file, OSV Material Library. This file is simply, I opened the OSV sample model that's provided with the Maestro installation and deleted all the geometry. The only thing left was the defined plates, beams, rods, springs, and so forth. So this gives us something to select from to assign properties in the model. For this particular ship, you can either predefine all of the plates and beams and things that are going to be used in the ship, or create them on the fly as you need them, which is typically what's done. But for purposes of the demo, we'll just use these as preloaded values. So now we import that, well, we use the PLY importer. Ming had modified this so that it also reads in standard PLY files as well as the output from these scripts. And so we'll go to the Maestro Rhino Module 5. And I like to click the transform nodal coordinates, mainly because Maestro uses positive Y in the vertical direction, and Rhino uses positive Z. Just to keep everything in the Maestro coordinate system, I like to transform the nodal coordinates. Otherwise, when it imports them, it will rotate the module. And rather than have the rotated module, I usually click this transform. Also, you'll notice that all of the units in here are currently in meters, which is the default for Maestro. Our Rhino model was in millimeters, so what we'll do is just change our length units to millimeters. And now it'll scale everything properly when it reads it in. Now you can see the frames that were created are on the outboard side. If we want to, we could either grab all of these and flip the normal, or since it was so easy, what we'll do is we'll come in here, grab these two polylines, and we'll flip the direction so that they're running in the opposite direction now. And then we can rerun the export script. We'll overwrite that module 5. And open a fresh copy of that file and import the PLY file again. Transform coordinates. They've dropped back to meters because we opened a new one, so we'll change that to millimeters again. And now the frames are on the inside. Now we're not going to be using the frames. We're going to create them as compounds from scratch. But if you wanted to, you could just use one of the predefined beams and use that as the frame. But it'll be a constant offset from the hull, and it won't really capture some of the shape in the corners there. You'll miss some of this additional material in here, so we're going to create that from scratch. The next thing we'll want to do is turn our frames back on. Since we are going to be doing this using compounds, we will need endpoints that define the inside of the frames in there. Now, since these are all pretty uniform throughout, we can just do straight lines. Since the interior of the frames and the frame thickness is fairly uniform, we can use the compounds to create the frames in here. Another option would be to individually mesh and create each one of these frames in the model. So the first thing we're going to need is an interior boundary. So I'm going to, just to make these easier to select, I'll group these and hide them. So if we ever need to turn them back on, we can just click one and grab the entire group to get them back. The next thing we'll do is to create a curve on the interior edge of that frame. Oops. I think I actually wanted to duplicate the edge. Oh. Did want to duplicate the, I'll select the frame, and we'll select, actually we want to select this frame and this frame. It selects all of the edges. The only ones we want to keep are this internal opening on the frame there, so we can delete the rest of those curves that were created. Now we can turn the curves back on, or the frames back off, and we will turn our endpoints back on. Now, for the time being, we'll turn the frames back on too, because what we want to do is each one of these frames will have to, when we build the compound, we'll need a corresponding endpoint on the inside of the frame that corresponds to these endpoints on the outside, so that we can build our quads and tris to construct the frame. So what we'll do is we'll take all of the existing endpoints built in Rhino and cut a section through them. And we'll cut it at the first frame and the other frame. And now we have the points there. We can turn our original frames back off. Now it gets a little confusing when we rotate into a view or we want to project those points inboard. So what we'll do is we'll use clipping planes. And we'll create a clipping plane here, and it's active in the perspective viewport. So as we drag that clipping plane back, you can see now we can see everything to this side of the clipping plane. We'll simply make a copy of it with Control-C and Control-V to copy and paste, and we'll flip the direction and move the clipping plane back to the other side of that frame. So now we can only see what's between the two clipping frames. Rather than hiding everything else, we can just limit the visibility of everything else. And what we'll do is we will take this curve and we will do a point projection so that we get the point that's closest to the curve, and we will just start projecting, and we can right click to repeat the command, and we'll just start projecting these points. And this way we'll be able to build quads all along the frame here. do a quick check for duplicates, just in case I accidentally clicked something twice. Now, the distribution in this corner isn't very good. Maybe we want to move this point a little bit. So if we have near ticked in the object snaps, we can slide this up a little. I'll just slide it up the curve to about midpoint between these two, get a better distribution in there. Most likely, if you visualize how these quads are going to be connected, we'll probably put triangles in this upper corner and then connect with a quad in there and then a quad here. And now we can grab these two clipping planes and go and basically do the exact same thing with this frame. Now you can see that there is a little shape change in here. There's more curvature as we move forward. If there was a larger change between these two, we might want to build each frame individually. But these are consistent enough that we should wind up with a pretty uniform thickness of the frame if we build it as compounds. But again, this is one of the choices where it's up to the user. And actually, one thing that we notice here is that we have 2 points very closely spaced, these two endpoints. I believe this is because there was a stiffener located very close to that longitudinal frame that was defined here, and we extracted the bottom edge earlier. So we'll have to check on that and possibly delete that stiffener from the model. Luckily, because we can export these things very quickly, it's pretty simple to do. We could also just fix it in the Maestro model. Also, that would be very easy to do. But for the time being, let's keep doing the closest point projections. That one's pretty close to the center, so we'll just leave that be. And as a quick check, so that we know we have the same number of endpoints at either end, just sort of visually line those up. Now, what we'll need to do is create endpoints connecting the interior of the frame. Now we can do that manually, going point to point. Actually, it looks like we're missing a point here on this curve. So we will do closest point, and I believe it was that one. And now you can see each one shows up in a pair. There are a couple ways of doing this. One, we can just create a line and manually click on each point. We can grab the points in pairs and do polyline through points. That also works fairly quickly. And with the right mouse button as a carriage return, we can work our way through here fairly quickly. Undo that. Some of this can be a little tedious, but goes fairly quickly. And we're done. Now these endpoints don't run all the way out to the module boundaries. Now we're done with the cutting planes, or the clipping planes rather, so we can delete those. If we turn our boundaries back on, what we can do is extend these curves, select those as our boundaries, and then start extending each one of these curves. All of them in one direction. Now we'll have to do the other end. And done. You can turn off those geometries. If we grab all of these curves, we'll check the direction because we'll need the endpoints to create the, actually we don't need the endpoints because these are just going to be endpoints imported into Maestro. We're not creating them into strakes. So we can grab all of these endpoints. And before we do that, if we need to export the hull again, because of that extra point, let's check that very quickly. We'll look at the, it wasn't a frame, it was the bulkhead. And it looks like there was a stiffener very close to the bottom of this bulkhead. So we're going to ignore that one. So we'll get rid of this point. And we'll have to get rid of the point on the polyline as well. We do that just by turning the points on and deleting that one point. And when we show endpoints, we'll have to ungroup them and get rid of that one. So now we should be in good shape to export everything. Now we can grab all of the curves, all the endpoints at once, run the export tool. We'll select the same polylines for making the connections into strakes. All of those endpoints that aren't included on these polylines will just go in as endpoints. They won't be formed into strakes at all. And we'll replace Module 5 again. And now if we come into a fresh copy of Rhino, we can import the new version of Module 5. We transform coordinates, remember to set our units. And now you can see we still have the hull and deck strakes and the additional endpoints from what we're going to use for the interior of the frame. Now right now we have just a single bay in the module, so or a single section rather. So what we will do is come in, and instead of having one 4.3 meter section, we'll create, and we'll go back into the Rhino model quickly and verify our frame spacing. And 870 millimeters in the X direction, and that is uniform throughout the module. So we will come back in here and make 5 870 millimeter sections. You can see we have now our frames at each one of those. But the aspect ratio on a lot of these straight quads is a little long. So if we want to make that closer to 1-to-1, what we can do is simply remove these 5 and instead add 10 5-millimeter sections. If we do this, we're going to wind up with twice as many frames as we want. So under default values, what we'll do is change from 1 section per bay to 2. And actually, we don't need 1 at the reference end because we're going to make a bulkhead here. So make those 2 modifications. It deleted the frame at the reference end, and now there are 2 sections in each bay, or in each frame bay. And now we have a nicer aspect ratio on our straight quads. We're actually going to build our frames from the compounds. We're going to build them up so we can remove these frames. The easiest way to do that is as a group modify operation. So we'll create a group and we'll start adding elements. We can add full strakes, although deleting a frame or setting the frame property on a strake, whether you select a single quad from the strake or the entire strake, it will get set for the entire strake. Easiest way to select them all is probably just to grab a box and put them all in there. And now we'll do the modify. We don't actually have to create the group. We can do modified properties from when the group is just being defined. And we'll just turn our frame, or switch our frame property to be none instead of the initial one that was assigned. And once we modify that, all of our frames are gone, and we can start to recreate them as a compound. First thing we want to do is create a new compound, and we'll give it a name. We'll create that compound. Now that it's created, we can start adding things to it. We're not going to need the springs, rods, or beams, but we will be using the tris and quads. So we'll add our first quad, and we will make it, we'll just start off with half-inch plate with no stiffener layout. We're just going to put the plating in there. We'll pick our nodes for the 4 quads and add it. And you can see it adds it at every node along the length of the strake, but we'll change that rule in a little bit. For the time being, we'll start adding additional quads. Oops, I forgot to create a new one. And you can see at this oblique angle, we start to get nodes that overlap a little, or endpoints that overlap a little. We want to make sure we're grabbing the nodes at the endpoint. If we didn't, and we started accidentally grabbing, let's say we grab that node instead of the one at the end of the module. If we create it, now each one of those frame quads is going to the next section. So we can simply just go in there and correct it. But to make it a little easier to select, we'll turn on a cutting plane so that we only see the nodes at the end. To keep things a little more square, we'll add a tri in there and make the next quad a little further over. We'll add a tri to fill in the gap there, use the same plate. and we can just keep continuing around. At this point, I'll pause and quickly make the rest of the frame out of quads and tris. And now we've completed the frame, except for this upper corner where we need 2 more triangles. But it looks like this will be a fairly narrow triangle in there. So what we might want to try is to grab this quad and change the second point, and the arrow on the top defines node 1, 2, 3, 4. The arrow is always from first to the second node. So if we move the second node to here, modify it, we can get 2 triangles that probably look a little better. And now we have our finished frame. If we delete the cutting plane, we can see we have too many of the frames. So what we'll do is we'll set the rule. We will remove the frame from the node 0 and node 1, the end of the module, and the next one in. And we want to keep the frames at 2, 4, 6, and 8. And now you can see we have frames at all of the appropriate locations. And we'll build a bulkhead for this end of the module. The bulkhead at the opposite, the other water type bulkhead at the other end of the module will belong to the next module forward. And there was also a frame in here where we want to create a new strake. We could have done that with one of the line connections when we were creating the deck and hull strakes in Rhino, but it's fairly easy to just do it here. One thing to be careful of is when they are imported from the Rhino script, each one gets a name, and the names have to be unique. The names just correspond to the ID number. So when we're going to create a new one, if we create a new one, it's going to create a new ID number, but keep the same name, which Maestro won't allow. So we want to just delete that. It doesn't have to have a name. We can do blank name is perfectly fine. But by selecting one of the other ones, it grabs all of the properties that were associated with it. So we're going to keep the same properties, and we will insert it from this endpoint to this endpoint. And now we have our frame. Going back into Rhino and create the bulkheads, or bulkhead. First, we'll turn off the frame and bulkhead layers, and we can hide all of the endpoints and points for the frames that we had created earlier. We can also hide the 2 polylines that we created for defining the strakes. And we will create our bulkhead from these points along the perimeter of the end of the module. So the first thing we'll do is we'll grab all the deck points, and we'll create a polyline through those points. Next, we'll make a copy of that polyline with cut and paste, and then we'll use the set point command and reset the Z value to move that copy of the polyline to the bottom of the section. Now we can grab those 2 polylines and loft a surface between them. By default, it'll create a normal surface, but we could use straight sections. Normal surface will work fine. We say OK, and you'll see that we have knots in the surface along all of our, because it was extruded from a polyline, or lofted between the polylines that were defined by these points. We wind up with a knot at each one of those essentially deck stiffeners, each location. But we don't have any in the vertical direction to tie into our endpoints on the side shell. So what we'll do is we'll select that surface and first make sure it's first degree in both directions. So we'll, under Edit, change degree, we'll verify that it's first degree in both directions. And then we will, under Edit Control Points, we will insert knots. If the knots were going to be inserted vertically, you can simply either manually select the direction or toggle and switch to the other direction. We'll need a mesh knot at approximately the height of the cross structure. This outboard knuckle location is a nice spot to insert one there. We'll simply work our way down the side shell at each one of those stiffener locations and keep the spacing somewhat even, so we wind up with a nice looking bulkhead in there. Now we have a surface that has knots in both directions. If we were to turn on the control points, we see we have a control point at each intersection, but this is a surface and Maestro can't import a surface. So what we'll do is convert it to a mesh. We can simply create a mesh from the NURBS control polygon, which we just looked at, and now we have essentially a surface and a mesh that look pretty much the same. We can delete that surface, and now we just have the mesh. If we turn the points on the mesh, you can see we have a vertex to use at each one of those intersections. I'm going to increase the size of that window so we have a slightly better view. You can see we have a lot of extra mesh quads outside the hull over here, but Rhino has some nice meshing tools that make it fairly easy to adjust our mesh to tie into all of these points along the boundary of our module. We want our point-to-point connectivity between our bulkhead and our longitudinal shell plating. So first thing we'll do is delete some of these extraneous mesh faces. And we can delete a few more in the lower areas here. We can also hide that polygon or polyline that was used to create the original surface. And next we'll come in and turn on our mesh vertices, and we'll start dragging them so that they are coincident with the points or endpoints that we created earlier and are already in our Maestro model. One thing to be careful of is that while this point appears to be very close to the endpoint, it wasn't exactly on it, and we will need point-to-point connectivity, so we have to make sure that all of those are also on there. The deck should be fine since that was the polyline that was actually used to create the surface. Those should be exactly where we want them. The rest of these we'll have to drag over and make them coincident with the points defining our shell plating. Some of these, like this one's halfway in between. We may want to split some of these. The easiest thing I think to do is to run around the model and move all of the ones that are very close, where it's fairly obvious that you'd want the endpoints to tie into, or the mesh point to tie into the nearby endpoint. That was another spot where it was just off by a slight amount, but we need to, and sometimes it's easier to move those points away from the point and then back, just to make sure that you've actually snapped it to where you want it. Now there's a couple options when we get into a situation like this. We could use in the mesh tools the split edge, split a mesh edge, and split it all the way at one end, so you're basically bisecting the quad. Or another easy way of doing it is to just delete that quad and then add a mesh face and select the two edges nearby. If the two edges meet at one end, it'll create a try. If they were, say, this edge and this edge, if we had deleted this quad and we selected the two opposite sides of the mesh, it would create the quad. And we'll wind up with a similar situation here. Actually, for this one, let's undo that and drag this point down, and then we can, well, let's split this edge. And we can rejoin that into a quad. And we'll have to turn the points back on. Let's grab all of these points and move them there. And then we can delete that try, and we'll move these points up and delete that quad and add a try back in there. And for this one, if we came up here, we wind up with a very flat-sided quad. So what we'll do is delete that quad, replace it with a try, and then we'll split the edge right near that point. And now we'll just there's two mesh vertices there. Now, occasionally, to clean up the mesh, what we can do is, if we select the mesh, there's a command for welding selected vertices. If we just select all of them, for many of these splitting operations that we've done, if the mesh vertices are coincident and they're part of the same mesh, it'll join them back together. So now when we turn the points back on, you'll see where we had two mesh vertices previously, we only have one. So it'll clean up the mesh a bit. And for this one, I think what we'll do is we'll leave these triangles down here. So we'll take our mesh tools and delete that face and replace it with a try. And we'll do something similar to what we just did earlier. Deleting that quad, replacing it with a try, and then we'll split the edge near that point and move those vertices out onto our endpoint. So we're nearly done. We still need to create this try and a quad up here. That's a simple splitting of the edge. We'll merge those two tries back into a quad and make sure we move our mesh vertex back onto the endpoint, and similarly on this edge, we'll need to split that edge, rejoin these two into a quad, and make sure we move that point back in. So now we should have point-to-point connectivity with all of the existing shell plating endpoints. The next thing we'd want to do would be to put some vertical stiffeners on this bulkhead. To do that, we have a script that puts beams on meshes. If we load that script, it presents you with several options. The first is polyline and direction, and that's if you had a simple polyline in space, you could select that polyline and define a direction, and it would extrude a beam along that polyline in the direction you selected. You could also do polyline on mesh, where if you had a polyline that was coincident with this mesh, say along that series of mesh vertices, vertically, you could select the polyline and select the mesh, and it would create the beam along that polyline and extrude it normal to the mesh. The next two, mesh and direction, one will just create polylines on the mesh. The other one will actually export the beams. But both of them do the same thing, where you will select the mesh, and then it'll ask you to define a direction by selecting 2 points. In our case, we'll select the vertical direction for a vertically stiffened bulkhead. And then it'll ask you for an angular tolerance, and it presents you with several options, but you can type in any angle you prefer. And it will, in our case, if we define the vertical direction and say 20 degrees, it will take every mesh edge in this mesh that is within 20 degrees of vertical and create a beam. It'll extrude the beam normal to the mesh face. And the last one hasn't been implemented yet, but it's similar in that you would select the mesh, a direction, and you would just click on different segments or mesh edges in here, and it would search the mesh from the edge that you selected with using the angular tolerance that you defined and create specific beams on the bulkhead. For now, we'll just do this sort of bulk creation of beams on the mesh. And first it wants us to select the mesh, then 2 points to define a direction. So we'll select the vertical direction, and we'll use, say, 20 degrees. The highlighted polylines are all of the mesh edges that are within 20 degrees of the vertical direction that we specified. It gives you the option to keep those polylines on the mesh if you want, or delete them after it's exported the beams. I usually delete them just to keep the model a little cleaner. And it asks you for a name of the Maestro neutral file for these beams. We'll just call it beams at the moment. And we need to export our polygon mesh to be used as the bulkhead PLY file, and we will call it bulkhead. And we'll just export the ASCII version of it, and you don't need any of the other attributes to be included. We just want the geometry. So now we can move back into Maestro, and if we import our PLY file, the bulkhead, we'll transform it as we did earlier. It's still in millimeters, so we're fine there. It's imported the bulkhead. It's at the aft end, and you can see we have nice point-to-point connectivity with our strakes. And now we can import the Maestro neutral file that contains our beams. And again, we'll transform the coordinates. We're in millimeters. And we have a beams module. Now, these beams, the normal of the bulkhead was forward, so it created them on the forward side of the bulkhead. But you can see it created some along the outboard edge, coincident with the shell plating, which we don't want. Since each one of these imports comes in its own module, it makes it very easy to just look at one of them. So we don't want these beams on the outboard shell. We don't want these beams on the inboard shell. And it created a beam on the center line, which we're not going to use since there's no deck or cross structure or stiffener on center line. So we can just use the deletions dialog and quickly remove all of those extra beams. Now if we hide the module and just look at the other two modules in here, the beams and the bulkhead, we can see that we're missing a couple. There should probably be a beam here. And the bottom of these beams, those last segments were outside the 20-degree angle tolerance, so we'll need to add those segments back in. Right now, we cycle the points display. All of these nodes that we see are on the bulkhead mesh. the beam or bulkhead module. The beam module only contains nodes that are defining the current beams. So in order to add a beam segment to the bottom of this vertical stiffener, we'd have to create an additional node in the beams module, because the beams module has nothing to snap to down there. The other thing we can do here is, since we've already deleted the extraneous beams that we don't want, and now we're just adding, we can merge these two together, and then we'll have access to the additional nodes from the bulkhead module when we go to define our beams. So we'll just merge these together, which is simply done by dragging and dropping the beams on top of the bulkhead. Now both of these are in the same module. So we can turn the visibility of module 5 back on. It's not currently the view part, so we still can't see it. But now these are all in the same module. So we will open the beams dialog, select one of the beams that was already imported. It comes in with the property of sample. That's created by the script, and all of these beams, whenever they're imported via the script, will have the property sample, and we'll just have to change them all. But with the group modify dialog, that's very simple to do. So we'll create a new beam segment here, and we'll run from these two nodes. We'll leave it with the same normal and property from the originally selected beam so that everything matches. We'll create another one to finish off the bottom of that beam and finish off the bottom of that vertical stiffener. Now to change the properties on these, we can just create a new group, grab one of these beams, and then add by property. Since they all have the exact same property, now all of the beams that were in this module have been selected into the group. If we modify the properties, we can change the beam type to any of these predefined beams that we have already in our library. So we'll make these, let's say 6 by 4 by 3/8. If we only wanted to do part of them, say you wanted larger beams at the bottom and smaller beams at the top, when defining the group, we could have just selected certain beams. You can always remove items from the group here, and then just group modify those selected beams. To do the bulkhead plating, we can also similarly create a new group and then grab one of the elements from the bulkhead, and we'll do add by seed, which will give you an angular tolerance, and then you can also specify limits into how far it should search to grab adjacent elements that are within that angular tolerance. Sometimes it doesn't grab everything, and you may need to manually add some of these back in. This could also be done with the box select. Or add by property or other things. But when we modify the plate properties for all of these, let's make this bulkhead 5/8 inch plate. Now if we were to go in and query one of these quads, you'd see it's now 5/8 inch plate. Go back to the top view part, and I guess at this point let's save our model, and we will save it as module 5. Now we can add the longitudinal stiffeners. Again, we'll use the group modify dialog. We'll add some strakes. Actually, the bulkhead is still our current module, which is why when we went to select these things, it it put them in the group, but it didn't remove them from the graphical display. So we'll put these back in the model, change our current part, and now when we add them, well, let me reopen that dialog. I think because we changed modules with the dialog open, it didn't refresh what was available. But if we grab the strakes now, not sure why they're not being removed from the display. But if we change the girder on these to, let's say, 4 by 3 by 1/4, you can see we just added stiffeners to each one of those strakes. Now, we've got one on coincident with another strake, so we want to remove that one. And we can do that individually and just go into the girders and turn it off. And I'll refresh the display. I think it's my graphics card on this computer. I guess that usually on other computers it'll refresh automatically. This one, sometimes I need to manually refresh. But based on the normals of these strakes, we know that this girder is associated with this strake. So now, to finish off the deck, we will open a group dialog and add these strakes and put 4 by 3 by 1/4 stiffeners on each of them. For the hull, we'll do the same. And we're skipping certain strakes because we don't want to put a stiffener at the knuckle. And we don't want them at the center vertical keel that we're going to create. And we'll just use the same one for these as well. Now, one thing I had forgotten to do when we did the frames was to put combing on the inside. So what we'll do is we'll quickly go back and modify those compounds. And to do that, we will make Module 5 our view part, edit the compound, and turn on the one temporarily at the end here. And like we did before, set a cutting plane, make it a little easier to see where those elements are. And we will add a beam. So we'll put a beam between those two nodes. And we'll make it say a 4-inch by 3-inch flat bar. And for the normal, we'll set a direction and we'll make it face forward. We'll do 100 so that the normal is in the positive X direction. When we add it, you can see we now have a beam there. And then we just start walking around the rest of the frame. I'm going to pause the recording for a second and finish off that interior combing. Now the combing was just finished. You can see have it all the way around the opening of the frame. We'll delete the cutting plane so you can see that it's been added to each one of the frames along the compound. And then we just have to go back and reset our rule to remove the one at the end where the bulkhead is. And now our frames are done. We'll change the view part back to top. And at this point, we just need our center vertical keel. Now, the bulkhead at the end isn't going to line up quite right with our center vertical keel. First, we'll create the strake for it. And we will make it out of, let's say, 3/4 inch plate. Has no frames, no girders. And this one we can name CVK if we like. We'll modify that to add the name. And we can add a small flange to the top of it. So we'll create a beam. And we'll set the direction to be transverse. And we'll use that same 4 by 3/8. We'll make it 4 by 3 4 by 3/8 flat bar. These can all be changed later, just for demonstration purposes. And to quickly add the beam along the rest of the top of the keel, we can use the Nodal group dialog. This one you don't have to create the ID for it first. You can just start adding nodes. But one of the things you can do in the Nodal dialog is to create beams quickly. It'll use the last created beam, and for all of the nodes that you select, you can right-click and then say Create Beams. And it will create, based on what the last one was, create all of those beams. So now if we go back in here, create another beam, and we'll put this in the opposite direction. So basically each one is half of the flange. Then we can go back in here and quickly create the other half. The last thing we'll need to do is to make sure that that ties into our bulkhead at the end. The easiest way to do that would be to move some of these nodes. So we'll make our bulkhead the current part. We can measure where this node is. It's at y = 0. So we will modify this additional node to y = 0. Make sure everything is turned on. Actually, I wanted z = 0. So we are going to put that back to where it was. We'll just copy that location from an adjacent node. Grab this one. Put it back vertically, and we'll measure that node. It has a z value of 2650. We will move that node to 2650. And the simplest thing to do would be to pull this node down as well. If we wanted to, we could just move it over and then create a couple of triangles in here. But for simplicity's sake, let's just grab that node and place it directly on that endpoint. And we'll have to grab the node that's being used to define the beams because they came in 2 separate modules, and also place it on that endpoint. So now everything is connected. The last thing that we would need to do is to assign properties to, say, the plating. So if we grab all of the deck plating, we can modify it to be, say, 1/2 inch plate. We can then grab the outboard plating and the inboard plating. We'll grab this cross-structure plating. modify that to be, let's say 5/16. These are all just so they have some properties associated with them. I believe we already if we would like to, I guess, view by ID, we could view by plate property. You can see what's been assigned by ID. Let's see what these strakes are. They are 1/2 inch, and these are 5/16. So we'll grab these strakes and make them 5/16 also. But that is basically how to quickly make a module using some of the scripts from Rhino. And we would be more than happy to answer any questions about it. Thank you very much.